A lambda A is 4, lambda S is 8, MM2 is in steady state. And we are asked, what is the probability a new customer will spend more than an hour in the queue? The first thing we do is we note that lambda A is less than, strictly less than k minus 1 times lambda S. And so that means we'll have a steady state, but also it means that we'll be in the non-gamma case. So we're going to be looking at a sum or a difference of two different exponentials for the steady state customer time. In particular, we know that the density function for the steady state customer time is ft customer of t is equal to 1 minus b2 lambda s e to the minus lambda st plus b2 times 2 lambda s minus lambda a e to the minus 2 lambda s minus lambda at. To be able to find this density function, we need to know b2, and we also need to know r. As always, r is lambda a over lambda s, which in this case is a half. b2 is minus pi 2 lambda s over lambda s minus a times 2 lambda s over 2 lambda s minus lambda a. And then we could substitute for pi 2 being pi 0 r squared over 2. But r squared is a quarter, so r squared over 2 is an eighth. So we're left with minus pi 0, 1/8, and then we substitute in lambda s is 8, and lambda a is 4, and we get 8 over 8 minus 4, and then times 16 over 16 minus 4. Once we simplify all that out, we get b2 is minus pi 0 times 1/3. And at this point, we have the reality that we need to find pi 0. However, pi 0 also has a simple form. It's the sum from j equals 0 up to k minus 2, but k is 2, so it's just the sum from 0 to 0, one term, r to the j over j factorial. Well, that's just going to be 1 because j is 0. It's going to be r to the 0 over 0 factorial, 1 over 1, which is 1. And then plus r times k, but k is 2, which is just going to be 2r over k minus 1 factorial, which will be 1 factorial, which will be 1, times k minus r, and that's going to be 2 minus r. And then all of that then to the minus 1. We're going to be left with 1 plus r times 2 over 2 minus r to the minus 1, which is 1 plus 1 over 3 over 2 to the minus 1, which is 3/5. If we substitute this 3/5 in for b2, we have that b2 is minus 3/5 times 1/3, which is minus 1/5. And at this point, we could just evaluate the probability that the customer time is greater than 1, and that is the probability of t cust greater than 1. So that's equal to the integral from 1 to infinity of the density function for the customer time, and then we can substitute in and break it using linearity into 1 minus b2, the integral from 1 to infinity of lambda s e to the minus lambda st dt, plus b2, the integral from 1 to infinity of 2 lambda s minus lambda a e to the minus 2 lambda s minus lambda at dt. Then we can just use the exponential reliability to evaluate those integrals, and we're left with 1 minus b2 times e to the minus lambda s times 1 plus b2 e to the minus 2 lambda s minus lambda a times 1. And these then simplify to 6 over 5 e to the minus 8 minus 1 over 5 e to the minus 12, which is approximately 0.000401.